Okay, so this is MN6 statistics. So this is our statistics class. If you're writing on regular sheets of paper, you should write the date. Okay, in college as well, you're going to want to write the date so that you can organize your notes later in order if you're not in a notebook. Okay, so this is MN6, and this is talking about conditional and marginal. Oops, I spelled marginal wrong. Marginal distributions. Okay, so we're going to have to write the data down. Okay, so this is exit poll data. Okay, so this is exit poll data or exit poll results. Okay, and this is from the 2016 elections. Now, just so you know what an exit poll is what people say to another person when they exit the polling place. So they are asking, say, 1,000 people, 2,000 people, however many people they're asking, but they're asking people as they leave. So later on in our class, we'll have to talk about how sometimes polling results are not accurate depending on different things. You know, if people are being attacked for voting for one person, then if any person asks them who they voted for, they might not tell the truth. So you don't, and actual election results aren't always the same as polls because of things like that. Or say they were asking questions about drug use and somebody asked you on the street if you vape, you might say no, depending on who asked, right? So if it was a younger person your age and you do vape, you might say yes. But if it was an older person, then you might say no. So there's some of that when they ask these polls as well. So specifically exit polls are polls that when you leave the voting booth, somebody asks you, you know, a certain feet away, 300 feet away, and they ask you about, you know, what was most important to you in the election, who did you vote for, things like that. And so that's what an exit poll is. Okay, so these are results from an exit poll. Okay, so this is Clinton. Okay, so Clinton, Trump, other. Okay. Okay, and these are real numbers. I don't know where Dr. Shelton got these numbers specifically. Like, was it exit results in, you know, was it nationwide? Was it only in one state? Was it in California? Was it in another one? So we don't know. Okay, so you can be a Democrat. You can be registered as an independent. You can be registered as a Republican. And then you can actually be registered as other things. Okay, so you could be registered Green Party. You'll learn in civics. There's lots of things that you could be registered as. Total and then total. Okay, so this would be the data that you would see in the textbook already. And our textbook's old, so she likes to have more new data in her class, in her notes, because she wants to make sure that we're kind of up to date and not just looking at old data all the time. Okay, so I'm going to write the numbers in. So 923, 79, 31. And then does that make sense? Just looking at the data? Right, what's Clinton? Is Clinton a Democrat or a Republican? Yeah, she's a Democrat. So it makes sense that most people who are Democrats would choose to vote for Clinton. It'll be interesting. We'll be able to look at this data after the other election because you'll still be in my class. Okay, now for Republicans, where would you expect most people to vote? Yes. Now, what is interesting sometimes, though, is sometimes there might be people who say they didn't vote for Trump even though they did. Because it's no fun being attacked online. Okay, independent. This one's what's interesting. Independent. Now, it does look like more people voted for Clinton in this exit poll at this moment because it looks like there were more Democrats, right? But if you look, we really need to find the percentages. Okay, we really need to find the percentages because there's less people over here. Okay, and then this is just people they were asking. So, and then this one is independents, 332, Trump, 377, and then other was 120, which makes sense. Independents would more likely vote for another party. But there are also other things that aren't included, like the Green Party. And there's lots of people who voted for the Green Party as well, with Jill Stein was the person. And then how would I find these other numbers here? I'm going to change colors. But how would I find the other numbers? The totals. Yeah. So, and I have them listed, so I'll just write them here so you guys don't have to add them. So this is 1,033. This is 829. And this is 833. So there were a lot more Democrats in the area where they asked this question. Yeah, and sometimes that's a problem with polls too, is that it's called oversampling. So they oversample one party, and when they over ask one party, then it looks like that person's going to win because they've asked more of that party. So they've asked more Democrats or they've asked more Republicans. So it depends who you ask more of. Okay, and then I call this the total. Okay, but the overall total was how many people they asked. So they asked 2,695 people. So that's now. I teach this concept in math analysis honors. So I've been teaching this concept that I'm going to teach you here today for about 20 years. So I've been teaching this specific concept a long time. But I do find that the wording of the questions always feels confusing. So when I write the test, I'm going to write the question as clearly as I can so that you can figure out what the answers are. Okay, so sometimes they're a little bit confusing. When they ask, they'll say, like, what percentage of Republicans voted for Clinton? And they might ask, what percentage of voters for Clinton voted Republican? So they word it in different ways, and then it means different things. So it gets a little confusing. Don't feel like all of stats will be like this, which is confusing. And then make sure the test I'm not going to write in a confusing way. Okay? Okay, so what we're going to talk about today is we're going to talk about how to find a lot of data, but there's some terms. One's called marginal distributions. Okay, so marginal distribution, and I want to show you what that is. Now, marginal distribution, I've always heard it called marginal probability. So a marginal distribution is if you look at just the margins. So I'm going to highlight so that we can tell the difference between marginal distribution and something called conditional distribution. Okay, so a marginal distribution is when you're in the margins, which makes sense, right? So this would be a marginal distribution. Okay, so if this is a marginal distribution, not a marginal probability, but a marginal distribution, and I feel like when I was watching Dr. Shelton's video, like I said, I've been teaching it for 20 years, but I feel like the way that she worded some things was really helpful, and I want to word those in the same ways to you. So we were always talking about probabilities. We weren't talking about distributions because that's not a topic in our math analysis honors course. So for this one, though, if I wrote the numbers, okay, so, and then if I'm writing a distribution, I should put a title. So the title of those numbers would be what? Frequency, right? And you could just put FREQ if you wanted for frequency. So frequency of that, frequency of this, and frequency of this, right? And that would be the distribution. I can write the total, right? But the total isn't necessarily written in the distribution. Now, what would be what I write on the left then? So if that's the marginal distribution, what are the labels? So the word distribution is kind of how all of the numbers are distributed. They're not asking for probabilities. The probabilities are the ones that are a little bit more confusing. So what label would I put on the 191? So what do you think? Can you tell from the table? What is the 191? So what does the 199 mean? So follow it in the chart and see if you can find it. Yeah, so the 191 is the other. Yeah, it's the other total. So we'll just call it the other, right? That's not broken up. And then what's the 1185? Yeah, so then this would be the Trump and this would be the Clinton. And this would be what? Candidate, maybe, if we were labeling it. Okay, so that's called a marginal distribution. So that just this is the answer for a marginal distribution. That's just saying how is the margin distributed. What's the other marginal distribution? Do you have another margin? What's the other margin? I'll make this one wiggly, but I'll make it yellow still. Yeah, the bottom. So this is also a marginal distribution. Okay, so I don't know if I would write it sideways though. I could, but I kind of feel like I like my charts like this. So this one would be what? 1033, but you could, if you wanted, you could write it the other way. 829, 833. And then what would be the 1033? So these are the Democrats that they asked in the exit poll, right? So this would be party. And then 829, independents. There was a lot of independents in the people that they asked. And then Republicans were these, right? And this is frequency again. Now, could you change these into relative frequency charts if you needed to? Could we add a column and change it to relative frequency? Because relative frequency might be interesting to find, but it depends what they ask for. So let's not do it, but let's say can make another column for relative frequency if it's asked for, right? So if it was asked for. Okay, now, and then again, we're just talking about terminology. Okay, so we're going to talk about the distributions first, and then we'll talk about the probability. And then I'll show you the part that I think is kind of difficult. Okay, so conditional distributions. So conditional distribution. So a conditional distribution is when you're only looking at one group. So you're not your total, like if you notice on these, the total for this is 2695. And the total for this one is 2695. So marginal distributions are looking at the overall total as your bottom numbers. Okay, but in conditional distributions, you're not. So the conditional distributions, you're looking at just one column or one row. So basically a conditional distribution, and there's this word in probability called conditional probability that probably you didn't see because you would have seen it in second semester algebra 2. And you know, distance learning really screwed that up, right? So you probably haven't seen conditional probabilities very much, if at all, maybe in middle school, but probably not. And not with your high school brain. Okay, you guys, your middle school brains function differently. Okay, so you wouldn't really have understood conditional distribution even if they taught it back there in middle school. Okay, so conditional distribution. Okay, so let's write the numbers down. Oops, except, so conditional distribution is like you're limiting to one column or one row, or one row in the middle. We'll call it in the interior. Sounds good? In the interior of the table. Okay. So for this conditional distribution, I'm going to leave a little space above my chart. Okay, so this is 923, 79, 31. And technically the total is not in the distribution, although it's helpful when you're finding relative frequency. This is a 79. Okay, and these were what? These were Democrats. Well, this is still frequency though. So let's call this frequency. So those are still frequencies, and those are still Clinton, Trump, and other, right? Should we just put Clinton, Trump, other? I guess that's being lazy. Okay, let me just write the words out. Clinton, Trump, and other. So this is the candidate. But I didn't write anywhere that we were only talking about Democrats. So I kind of feel like for conditional probability, I should put of Democrats. So I feel like I should write this also. Of Democrats, here is my, if I'm looking at Democrats, what percent voted for Clinton? Of the Democrats, which ones am I talking about? So this might help you understand the weird questions that I feel like they ask you. And we have to be able to answer them. And this is how they manipulate you when you're an adult, sadly, is that they exaggerate numbers and they make it seem like they know what they're talking about. So like right now they're saying COVID deaths, or they're not saying COVID deaths, they're saying COVID cases are going up. That's not necessarily true. It's just there were a lot of people with COVID before that weren't tested because there weren't enough testing kits. Oh, is that you answered my question of what percent of Democrats voted for Clinton? Is that where you got the 89.3%? Yeah, that's cool. We should write that because that's actually interesting information. Okay, but for the COVID things, is they're not talking about the deaths. You know, and when they talk about what percentage of people, they weren't talking about the of properly. And so it skews things and it confuses the matter. And then we're manipulated by the fact that it's like, well, 10% of people died in Italy. Well, 10% of Italy didn't die. It's 10% of the people who they knew had COVID. But people who they didn't know had COVID didn't show any symptoms. So it wasn't 10% of all people. It wasn't 10% of the people who had COVID. It was 10% of the people they knew had COVID because they showed serious symptoms and went to the hospital. So the of really matters. Okay, so I think we should label it at the top. So that's my point of view. I think we should label it. I'm not sure if really in other people's statistics class they label it like that, but that's kind of the important part. Okay, so let's write another one. Let's write the of independence. Okay, so let's do all the conditional probabilities, and this is going to help you understand and how to answer all the rest of the questions. Okay, so let's do the of independence. Okay, so, and this is going to be a conditional probability. Okay, so a conditional distribution because we're writing it all out. Okay, I probably shouldn't put a line under there. Okay. And then this is going to help you understand the questions when they ask you, and it's kind of confusing. So the first thing let's do is put the numbers in. So 332, 330, 377, and 120. Okay, and this is still the frequencies. So we have to put frequency, but I see why I would want to put independent at the top, but it's the frequency of independence. So that's why I'm just going to put it at the very top. I think I lost my D. There's a D in independent. Okay. And then this is Clinton, Trump, and other. We'll just put that. And this is the candidates. Okay. So let's highlight that. Okay, and the reason this is called a conditional probability is because we're only talking about independents. We're not talking about the 2695 people altogether. Okay. And then what's our last vertical one? Of who? Who's our last of? And actually, when I teach my class of how to tell like which topic you're talking about, the of does matter. So this is of, yeah, so this is of the Republicans. Okay, so of the Republicans, what's the candidate? What's my frequency? Okay, so that would be, there's what, 40, 729, and then 64. And this is Clinton, Trump, and other. So later on, when they say of Republicans, how many, what percentage voted for Clinton, this would be the chart I'm looking at. Of Republicans, I'm looking at that. Now, what should these totals be? Okay, so the total over here, I'm just going to kind of write it to the side. Okay, so this total over here is 833. This total over here is 829, and this total over here is 1033. The only reason I'm writing it kind of to the side is because I don't want you to think that it's in the distribution. And wouldn't you divide? Like, if you would divide them anyway, so that's kind of nice. So those are the totals. So what is 1033? Like, what does that number represent? The 1033. What's 1033 mean? Number of Democrats. So that's the number of total Democrats. And that's what you divide by when they say the word of. So they're going to say something like, what percentage of Republicans voted for Clinton? And that word of is how you know that your denominator is going to be the total number of Republicans. And this will help you understand that a little bit more. Okay. What are the other ofs? Well, the other ofs are Clinton, Trump, and other. And you know what? Maybe let's write, I don't know if we should write this chart sideways. No, I really don't like writing charts sideways. So let's try to write it vertically as well. So this one, we're going to still put frequency, but we're going to put of the Clinton voters. Okay, so let's see if we can write it this way. So of the Clinton voters, and this is also a conditional probability because it's in the middle. Okay, but what are my Clinton voters' numbers? So my Clinton voters are across the rows, right? 923, 332, and 64. You know what? I have it on my phone because I need to scroll up so I could see it. Okay, so let me scroll up so I could see it. Okay, so of Clinton voters, there was 923. There were 332 in another category, and there were 64. Okay, so what's the 923? If I'm talking about the Clinton voters, what's my 933 or my 293? Yeah, so that's my Democrats. And then what about my 332? Those are my independents. And my 64? Those are my Republicans. So what would you put maybe as the title? What do you feel like you would put as the title? Party, yeah. And then my total is going to be what? Yeah, and this is total number of people who said they voted for Clinton, right? Because remember, it's an exit poll. So that's how many people said they voted for Clinton. And maybe that's true and maybe that's not true. But we're going to assume that it's true. But that's another kind of question with the bold. So this would be something they would say, and this is how I'm going to write it on the test. I'm going to be very specific. I'm going to say of Clinton voters, and then I'm going to put what percent voted Democrat, or what percent were Democrats. So I'll put the word of really clearly in there so you could see it on the test. But sometimes when you're reading problems in the book, it's hard to tell, like, what's the of? So what's the of is the most important question when you're ever doing this. Okay, so what would be another of? So what's another of I need to do? So what percentage of blanks voted for blank? Okay, so of Trump voters. So what percentage of Trump voters were Democrats, right? Of what percentage of Trump voters were independents? And what percentage of Trump voters were Republicans? And then this would also be frequency. Oh, I think I can see the numbers sideways here. 79, 377, 729. I'm reading across in my top ones here. Okay, and then what was my total number of Trump voters that they were asked in that area of that polling place for those exits? What was the total number of these? I don't have to really re-add them, right? Because we already have the addition. That's 1185. Yeah, 1185. 1185. Okay, and for your homework, I'm not going to have you doing, all of these charts. Maybe for one of them, it might help you understand, especially the ones that ask like a million questions. They ask all these questions, and you're like, what are they talking about? But I kind of think that this would be a nice like transition to be able to do that. And what's the last one? Of others? Okay, let's not do that one. I don't think that one's very interesting. I don't even know how I would ask that question. Of the people who didn't vote for Clinton or Trump, what percent of them were Democrats? We could do that, but let's not. I don't think any of her questions look like that. Okay, so let me zoom out. Okay, guys, I'm going to zoom out so I can see the whole chart. I know it's little, but I'm going to write the questions to the side. You can write the questions down. Okay, but I want to see everything that we wrote. Okay, so let me show you a sample question that they ask. Hold on. Hey. Oh, that's because that's a photo. I was like, how come it's not doing it? Okay, so what's this question say? Okay. Okay. That's kind of cool for the marginal distribution. She erased like the middle of it so you could understand it. But then every time, so every time she wrote a new question, she had a new chart. But we don't want to have a new chart for everyone. Conditional distribution of party affiliation for those who voted for Clinton. Okay, so that. Okay, so we did all that. Okay. Okay. Okay, this one right here. Ready? Okay, so this is a question they're going to ask you. So we'll put the questions. And these are the things that are kind of tricky sometimes when you're looking at the main table, especially if English is not your first language. So it's a little confusing on this part, but we'll get into the math more in later on too. Okay, so this one says, what proportion? Okay, so what proportion of Republicans voted for Clinton? Our second question, we're going to do that one in a minute, is going to be what percent of Clinton voters were Republican? And our last question is going to be, well, we're going to ask more questions, but our last related questions is going to be what percent of all voters were Republican and voted for Clinton. Now, some of you, when you read these, they're super easy to you. You're like, they're so obvious, Ms. Nichols. I don't know why you're saying they're tricky. But to some of you, they're really hard. Okay, so let's use our charts first. Okay, let's use our charts. So we have our marginal distribution charts. We have our conditional distributions chart. We have our big old chart. Okay, now the key is the of. So I'm going to underline the of. Of Republicans. So which 25 charts that are blue should I use? Do you see which one you should use? So of Republicans means I would use this chart if I had already drawn it. Now, most of the time, you're just going to have the big chart and try to answer the questions. But the idea of this is the only part you're looking at is going to be helpful. So what proportions of Republicans voted for Clinton? So the of Republicans goes in the denominator of the fraction. Okay, it goes in the denominator of the fraction. The of goes in the denominator. Denominator, don't abbreviate it because it's going to look like Democrats. So the of goes in the denominator. So what are all your Republicans? How many total Republicans do you have? Okay, so 833 Republicans. And remember, you typing chats is how I give you discussion points. Okay, so I give you discussion points based on how many chats you write. So if you're like, oh, I don't have too many, just type 833 because a bunch of people already put 833, right? So that's probably the right answer. I don't mind if you copy other people. Okay, let's see. So 833. And then what do I put in the numerator? What do you feel like you put in the numerator there? Yeah. Yeah? Okay. So then that's what you put in the numerator. So this would be 64. And then they said proportion. So that'd be fine. Or you could write it as a decimal, but not a percent. If it doesn't say percent, you can't write it as a percent. So here, let me use my calculator. So 64 divided by 833 is, you could write 0.077. You can't write it as a percent, so this could be the answer too. But proportions you can write as decimals or fractions. When I see proportion, I always think of a fraction, so not a percent. Okay, now, who's the of in question number 2? So we'll call this 1, 2, 3. Who's the of in question number 2? Who's my of? Clinton voters. Okay, so my of is Clinton voters. So I'm only looking at the Clinton voters. So I'm only looking at this one. Now, if you made the marginal distribution, if you didn't make the marginal distribution, you would be over here in the chart, maybe circling the Clinton ones. Right? So you would just be circling the row in the chart and saying, oh, I'm just looking at these guys. I know I wrote them in a vertical chart, but you could still see it out of those. Okay, so you could either make the conditional distribution charts, but I probably wouldn't want to draw them all, right? Or you can look in the main table. Okay, so of the Clinton voters, so now where does that go in my fraction? Where do those Clinton voters go? They go in the denominator. So what do I put there for the Clinton voters? And I'm just talking about the of, so I'm not talking about the Republicans yet. So of the Clinton voters, how many Clinton voters are in our exit poll total? So I'm going to disagree with the one person who was courageous to put an answer. We need some more courageous people to put answers so we could see if you kind of got the hang of it. Yeah. So the total number of Clinton voters is going to go here in the denominator. And this is called a conditional probability because I'm not talking about everybody. I'm only talking about just the Clinton voters. So that's called conditional. Okay, and how many, what do I put on the numerator? You know, I'm kind of fascinated by this. I don't know if she did this because she was doing this on multiple pages, but I kind of like that all these questions have a 64 at the top. So actually the last one is too. So really the difference is the denominator. And that really, sometimes my brother and I will be discussing things and, you know, they'll say something like, oh, 33%, or they'll say 22%. And you're like, yeah, but of what? And we always talk about how the of is the most important thing because it can manipulate the numbers. Okay, so this is going to be very valuable in your real life as well when you're an adult. Okay, maybe not this specific election stuff, but definitely when people throw numbers at you at work or in other situations. Okay, so of all voters, so what would that be when you write the fraction? Now, of all voters, I'm not going to look at my blue ones, right? I'm not going to look at my conditional probabilities. Oh, you guys, for number 2, I forgot to, Ari, is that you dividing number 2 for me? Because you guys, it actually said percent, so I would have missed it. I mean, I would have gotten partial credit, but yeah, she did write that. This is actually 0.049 or 8. I guess I would round the 5 up. But but statistics is very like, they would take in 0.048 if it was 0.049. They're very like, maybe just cut off the ends, maybe round. It's not quite as mathematical as ours is. Okay, so for this one, I need a percent though. So what percent would that be? Yeah, so 4.9%. So I actually need a percent because this one said percent. So we have to be careful and answer the way that it asks. Okay, so number 3. So good, you guys, because I wasn't done with that one. Okay, of all voters who are Republicans and voted for Clinton. So what's my of? What do you feel like my of is? I don't feel like conditional probability because I feel like they're talking about everybody. Yeah, so my all voters, I'm going to have to look at this number, right? My all voters is that number. Now, I could use any of the yellow numbers and then any of the blues in the middle. So basically, all the blues in the middle are your conditionals. And then your yellows in the margin are your marginals. Okay, but actually, this one is just a regular probability. So what all the voters? Tell me what number I put on the bottom. So I put the 2695 at the bottom. And I want to know of all the voters who were Republicans and voted for Clinton. Yeah, so 64. And did they say percent? So I should divide. And remember, we are talking about who's our who. Our who is the people who answered this specific exit poll. Okay, now if it was electronic and anonymous, you know, then it might be more accurate. Oh, you guys, I put the 0 in the wrong spot. Oh, that's pretty serious. Hold on. There we go. I don't usually put zeros in the front, so I mistake. So this is what, 2.3, 2.4 maybe? 2.4%. 2.4. So 2.4% of all voters in this exit poll said they voted for Clinton. And it's funny because Dr. Shelton, she is such an amazing teacher. She's actually the AP Stats teacher for 6th period. And I listen to her and I see her writing stuff down and I can see the difference between she and I because she's very into communication. So, you know, you would write the answers in a complete sentence because on the AP exam or in college, they're going to want you to write it in a complete sentence. But my math brain is mathy. You know what I mean? So to me, I'm like, oh, okay, we got the answer. But I mean, technically, the answer is 2.4% of all voters were Republican and voted for Clinton, right? In a complete sentence. And we could make the complete sentence, but I'm a math teacher still, so it's very difficult for me to like write answers in complete sentence. So we're going to focus on the numbers. And then when you guys get to college, okay, college, or if you decide to transfer into AP Stats, then if you're going to need to write the words, you know, that is a big part of statistics, is to write the words. Okay. Our class is to prepare you so that you can pass college statistics on the first try, because you can't take the AP test to pass you out of it, because there is no AP test. And we're not going to do all of the material that AP does. We're going to start slowing down from them. And then I don't know how fast, they don't really, I've never heard a complaint that stats goes too fast. And in fact, you guys, I'm the one who teaches the class before stats, the Algebra 2 class, and before AP Stats. And I found that my, even my weak students from Algebra 2, who were pretty good at English, did very well in Dr. Shelton's AP Stats class. So, and then I had one student who he was severely autistic, and he really struggled in math a lot. I was his tutor, and I kind of calmed him down when he was in geometry. He was kind of hysterical every day. And then I was his tutor, and then I said, oh, put him in my Algebra 2 class. So then he was in my Algebra 2 class the following year, and then I didn't tutor him, but, you know, just helped him out. And then I suggested that as a senior, he take AP Stats, and he took AP Stats. And then I think he ended up getting a C probably in AP Stats. And then he did not choose to take the AP test. He took college stats, and I tutored him in college stats, and I tutored him in AP Stats. And then he did pass the first semester. So there's only one semester in college, and you don't have to take like every year is a semester in college for their math classes. So anyway, so then he passed. So Dr. Shelton taught him enough that when he took college stats, he took it once and then done. And in stats, it's a class that sometimes people take 2 or 3 times because they've never seen it before. Okay, so this is going to be helpful for you if you don't want to take AP Stats, which that's totally fine. AP Stats will be, you know, will be more intense than my class. But if you want to, make sure that you do contact me. Okay, so anyway, sounds good? Sounds good so far? Sounds good so far? Let's try to answer. Let's see if we have another question. I think that takes care of her whole video. Let's see, we're at 10:25, we have a half an hour. Okay, I also want to show you about skewed distributions, but let me show you one more example, okay, that's a new chart. Okay, we're not going to draw all the charts. Okay, and maybe I'll make up my own questions. We'll have to see what the textbook questions have, how good they are. Okay, so example 2. Okay, that's a weird question. I don't know. That's not a good question. Okay, I don't like that question. Oh, I like this question, maybe. Oh, I like this question. Okay, this is better. Okay, so this is weather condition. The other one was about allergies and how many languages you speak. So I think those are not related. Oops. I think those are not related, which are okay. Those are called independent. Okay, so this is weather condition. Okay, weather condition and weather, let's see what it is. It's about a train and weather condition based on whether it's going to be on time, delayed, and that would be it usually. We're going to have a total, but total isn't technically part of the distribution. Weather conditions: sunny, cloudy, rainy, snowy. So not in California. Okay, so weather condition. If it's sunny, what do you think? You think if you're in the sunny category, which one do you think would be the most? On time or delayed? On time? Okay, so 167 are on time and 3 are delayed for a total of 169. But let's say we didn't have the 169. So let's pretend we don't have the 169. Okay, so we'll put those in later. Okay, cloudy. Cloudy is still not that serious, actually. So actually on cloudy days, it said that 115 were on time and 5 were delayed. Rainy days, interesting. So rain really affected the on-timeness. It's not half and half, still more on time. Hey, they're pretty good in the rain. Oh, look at the snow. 8 on time, but 12 delayed. Dang. Okay. So this is the information that they give you usually, right? And then you might have to find the totals. The distribution itself does not include the totals. But if you put the totals in your distribution for me, I'd still be happy and I'd still give you the credit. Okay. And then this is 35. This is 330. And then this is the total. This is what I refer to it when I was tutoring, when I tutor people in stats. My total, 365. Okay. So now they might ask you for just the distribution, which means you don't have to find the probability, but let's ask a question. So let's say of all the on-time trains, what percent were sunny days? So that's going to be question number 1. And this is the style that I'll ask the questions on the test. Of all the on-time trains, what percentage were sunny days? So now, I don't want to necessarily have to make my own distribution, but which row or column am I looking at for the total? So remember the of. And maybe I should use blue. Hold on, let me use blue because this is actually a conditional probability. So of the on-time trains. So am I looking at a specific row or a specific column? Okay. So I see the top number, right? I feel like the top number is 167. Do you feel like the top number is 167? But the question, what's the bottom number? So I'm only looking for the on-time trains to go at the bottom. So who are my on-time trains? So what do I put on the bottom? Yeah. So I'm looking at only on-time trains. So this is a conditional probability. And this would be the conditional distribution, right? But I'm looking for conditional. I'm not saying out of everybody. I just want to look at the on-time trains. Oh, that's interesting. So out of the on-time trains, that's like about 50%. So 167 divided by 330. So this is about 50.6%. And I'm dividing 50.6%. Okay. How about of snowy days? What proportion are delayed? So what do you think? Row or column? So I only want to be looking at the snowy days. So is that a row or a column? If I'm only looking at snowy days. So here's my snowy. So I only want to look at the snowy days. So what do you think? Do you feel like this is the only data that you would be looking at? Yeah, the row. Okay, so what would be the top number and what would be the bottom number? Mm-hmm. And it says what proportion. So probably I'd reduce. That's what, 3/4, 3/5? Or I would write 0.6. So I would take this answer. I would take this answer. You could put either answer and it would be fine. 60. I mean, I didn't ask me for percent, but 60%. Dang, that's bad, right? That means you probably are going to want to get on an earlier train because you're going to be late for work. Okay, so I will ask the questions in this way. Sometimes the book doesn't ask them that way. So you're going to have to try to like investigate how you're going to answer the question. Okay, and then the last one, it says what proportion or what percent of trains were delayed. Oh, and both of these were conditional, right? Because they were from the middle. These were both conditional. If they ask you, what percent of trains were delayed? Now, my of is a mystery, though. You see my of? My of is a mystery. Were they talking about of sunny, of cloudy, of rainy, of snowy, of on time, of delayed? They aren't. So that means it's not a conditional probability. So this one's not conditional. Because the of is everybody. Isn't this all trains? So what's my denominator for all trains? Yeah, so 360. Oh, that's interesting. That's funny. What's 365 for? You guys, where's 365 in the world of numbers? Yeah, it's the total days of the year. So they were listing all the days of the years of this downtown train. Okay. And then how many were delayed? So what do you feel like you'd put on the top? Yeah, 35, right? So which numbers did I use? I used 35 and 365. Where did both of those numbers come from? What physical location in the chart did both of those numbers come from? They did. They both came from totals. That's interesting. That's a good way to think of it. It's a marginal probability. This one's marginal because both the numerator and the denominator were in the margin. And what'd you say? You didn't call it the margin, you called it the total, right? In the totals columns. Okay. And they wanted a percent, so I need to divide. So 35 divided by 365 is 9.6%. Hey, that's interesting. That's like 1 in 10. 10%. That's 1 in 10. That's a lot of delayed trains. I feel like, oh, that's okay. We do it by chats anyway. So if you get logged out and log back in, it's no problem. So technically that's called a marginal probability. Okay, and then let me just do one more. What percent of trains were delayed and delayed on a rainy day? So we still have the of trains. So I feel like it would still be 365 because I feel like they're still talking about all trains. But what would you put in the numerator? What would you put in the numerator? Delayed on a rainy day? Yeah, delayed on a rainy day. And I got to stop putting percent because now I have to divide again. Okay. When it says proportion, you don't really have to divide. You could just leave it as the fraction. So this is 4.1%, but I kind of like the percents. The percents make more sense. Okay, this is actually not marginal. This is not conditional and not marginal. This is just regular probability that you learned a long time ago. Ability. Okay, so what do you think? Not too bad. Now, the testing will be okay, but when you're reading the homework questions, sometimes it's a big mystery. Okay, so don't get frustrated. Try to find the of. If you can find the of. Sometimes they don't specifically say of, though, so you have to try to read the English and figure it out. Okay, so I want to go, that's MN6. So I want to do MN7. Okay, so I want to do MN7. Let me see if I can send this to myself. I think it's not going to let me. It's too long to share. Okay, so I'll have to take photos of that one. Okay, so I'm going to go to the next one. So this is MN7. And this is descriptions of graphs. Well, I call them graphs, but actually she calls them distributions. I'm going to put graphs. These are in graphs forms. She had this cool acronym. What was it? It was SOCS. 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 I love Dr. Shelton and her acronym. So that's why I'm watching her videos, because she gives us, I remember when I was teaching my student, is I love how she gives a way to remember what things you're supposed to talk about. So what you're supposed to talk about, but we're going to not talk about all of them today, is C stands for center. You're going to want to describe where the center of your distribution is, your graphical distribution. O stands for outliers. S stands for shape. And S stands for spread. So when you describe a distribution, you're going to want to describe all of those items. Outliers are unusual values. So you would either say it has unusual values or it has no unusual values. Center is where approximately is your middle. And they talk about median or mean, and there would be some terms that you just kind of estimate where the middle is. Spread is how far apart your data is. And shape is one we don't really talk about as much. Okay, you probably haven't seen shape talked about as much. She mentioned some words that I thought were cool. Because remember, when I taught AP Stats, it was a long time ago. And then I teach this in IB as well, except this year, instead of teaching HL Math, I told them that I wanted to teach this class. So I took some pictures of these cool things that she was showing. And she gave a description here. I forgot what she said for the, unimodal. Yeah, but what else? Oh, symmetric. So for shape, you would say symmetric, or you would say not symmetric. Okay, so those are two words that you would use for shape. I wanted to tell you about skewedness today, so we're going to talk about skewed. There's kind of three things you talk about with the shape. Skewedness, let me spell that for you. It's Skewedness, skewedness. And this is going to be right, left, or center. And the last thing was, you might say unimodal, bimodal, multimodal is what she told me. The last one was multimodal. Okay. So for outlier, center, and spread, we can talk about that more later. I really want to talk about the shape today. We only have about 12 more minutes, but I really want to talk about the shape. So maybe I'll draw some graphs. I'll see if there's any in the book, but if not, I'll draw a worksheet for you, and then I'll have you answer questions on that. This is tomorrow's anyway. Okay, so tonight's is MN6, and then tomorrow's is MN7. I'm just trying to make the notes match the homework that you're doing specifically. So normally I would just have called this 1 day of notes and then have it. But I kind of like it so that you can find your notes. Okay, so she shows this really cool blob. I don't remember what she calls him, but like Mr. Blob. But okay, so it's this like did you see Transylvania? What is it? Transylvania, which is the animation movie with the vampire? Is it? It's not called Transylvania. What's the Hotel Transylvania? It is. Okay, so imagine the blob guy. Okay, so imagine the blob guy. Okay, so imagine the blob guy, but he has this tail over here. Okay, so this is the blob guy. So she shows a picture of him. He's blue. It's really kind of cool. Okay, so here's the blob guy, and this is his tail. The tail determines the skewness. Okay, so this would be called right skewed. I used to always forget which one was which. Okay, so if the blob guy is going this way, so here's his eyes. This is called left skewed because his tail is over here. And then skewedness, you guys, can we cross out center? You guys, right here, it's not called center. It's called none. Okay, so I was like doing margins. Okay, so right here, I'm going to highlight so you can see I changed it. We're calling this none. So it's not skewed. Okay, so not skewed would be one like this. And then what about symmetric? Do you feel like any of these three are symmetric? You feel like any of these are symmetric? 1, 2, or 3? Do you feel like 1, 2, or 3 would be symmetric? Yeah, so this one is also symmetric. So in describing the graph, symmetric. I would say this is not symmetric. And you guys, I just wrote this, if you didn't notice. No reason for the highlighter. Except that I wrote it later. Maybe I'll just highlight all the symmetrics. And what else did they tell us to talk about? Mode, right? Okay, so for these, and I'll highlight this one in another color, but this one, how many modes do you think it has? So a mode is like a mountain. So how many mountains do each of these have? Yeah, so all of these are going to be called unimodal. So what's uni mean? Oh, and that modal is AL. This is DAL, modal. Yeah, so uni means one. Okay. So what do you feel like bimodal would look like then? What's bimodal? Two, exactly. So this would be two. So you're going to have like two mountains. So for example, this one right here, I feel like it's somewhat symmetric, maybe not symmetric. I don't feel like that one's skewed. But you see how that's bimodal? And that's actually heights of men and women. If you plotted men and women on the same graph and their heights, there's actually two modes, like the modes for the women and then the modes for the men. So that one's called bimodal. And then I guess multimodal would be like, right? That's multimodal. Okay. So how about this one? How would you describe that one? So what are some words we would use? So we have three things we need to talk about. Okay, so bimodal is one. Okay, like the right. Right what though? Okay, not symmetric. Yeah, and this is right tail, so you remember. So this is right skewed. Oh, it's called, usually people put the word skewed in the front. So this is skewed right. Now, you guys normally they should be in a sentence. Like the distribution of the ages of heart attack patients are unimodal for both male and female. However, the male distribution is more symmetric and the female distribution is slightly skewed left. So that's kind of how you like describe it in words. Okay. Okay, so what? We have 5 minutes. Okay, so let's see. I'd like to do a. Let me show you this one. Okay, so let me show you two graphs. Okay, this one starts at about 40, ends at about 100. Okay, and then draw some squares in there. Some rectangles. I should have made my rectangles wider. Make your rectangles bigger. Okay, make this one. Okay, so that's one. This one is males. So this is, oh no, this one's females. Okay, so this one's females. I keep spelling male like mail truck. Females. Okay, this is females. This is males. And they're heart attack victims. Ages. Ages of heart attack victims. Okay, and then the males. Oh, and actually, this one kind of has more like that. A little bit at the end. Do you see the two I just added? I just added these two at the end. Okay, and then the males. Wow, that kind of sucks. So this is like maybe down to 35. Okay, now the males, it looks like it goes almost all the way down to 20. So there's some over here. There's a lot more males victims. And then they're little like same thing kind of on this side. Where's this one's center look? This one's center, it's hard to tell, but this one, the tallest part, the center over here looks like on my graph, It looks like maybe 70 is the middle. And for the women, actually, the women look like it was higher. So I guess I have a kind of a bad graph. So this one, let's draw this a little higher. So the women 80 was the middle. So I kind of have bad graphs over here. I should have taken a picture and then shown you. Okay, but if you're looking at these, let me just give you an example. So these aren't like the perfect graphs that I have here written on mine, but let's just look at our graphs. So you would say, you would talk about socks. Okay, so socks was your spread, or socks was your shape. So what might you say about your shape? So maybe women is skewed left. Let's just do the women graph. So skewed left. You would say maybe it's unimodal. And what was our other one? Symmetric. The one I drew is not symmetric. So write whatever yours is. So that would be for O. O is outliers. Do you see any extreme value? That would mean like you have one down here. So this isn't really here, but look right there. That would be an outlier. So if you just had a random value out in the middle of nowhere. So this would be none. The center, I don't know, is about 75 years old. Is the approximate center. But we're going to have ways to calculate these. And spread is, I would say, the ages from 35 to 100. Oh, is that the like 10-year-old that I just drew who had a heart attack? Right? Okay. So, and remember when you draw your blob, it's where the tail is for the skewness. Okay? Now our time's up, but you kind of have a good feeling of the idea on how complicated I ask the questions, right? Okay, now I know some of you are going to might want to do your homework right at this exact moment. So what I'm going to try to do, I have 6 period free. So what I'm trying to do is find some good questions for you. I'm going to start with what the AP Stats questions are. I'm going to see if I like them. If I don't like them, I change them. Okay. And today's homework is going to be on the charts. And then tomorrow's homework is going to be on describing graphs with the socks idea. Okay. Sounds good? So say goodbye before you sign off. Okay, say goodbye before you sign off. And then don't forget to come to tutorial tomorrow. It is required for my class. So please come to tutorial tomorrow. So I will see you at tutorial. Okay? I will see you at tutorial.